So, dear students, this is Dr. Venkatachalapathi, Institute of Aeronautical Engineering. I am going to discuss on wire drawing and tube drawing in metal form. In general, this metal forming process comes under the manufacturing process course, which was in second year, second semester, mechanical engineering branch. And this is a metalworking or mechanical working of metals. In this mechanical working of metals can be defined as it is the process of heating or at the room temperature the materials can be heated, and by applying the pressure and force to form a certain shape. So what are the required shape of the component to be produced in this metal forming process? In this metal forming process, the main thing is the wastage of material is minimum or negligible. So that is here. This metal forming mainly depends upon the another important term called the hot working. What is meant by hot working? So in general, the term hot working can be defined as it is the process of heating the metal at the above recrystallization temperature. We will call it as a hot working process. Under the hot working process, the major application for hot working is hot rolling process, hot forging process, hot tube drying, or hot extrusion process, these things. And similarly, when you are discussing about the cold working process, the heating the metals or materials at the room temperature. So, but only thing is, because there is no heating can be done in that material, obviously you need to require lot of pressures or high force is required to change a simple shape also. So that is why this wire drawing and tube drawing comes under the, obviously it's a cold working process. Now let us see in detail what are the important concept of the wire drawing, and similarly how it will distinguish between the tube drawing process, and what are the advantages, limitations and applications of this wire drawing and tube drawing. So in this session, I am going to give a brief idea about the wire drawing. Let us see the basic introduction of the wire drawing process. In metalworks, wire drawing and tube drawing is a stretching of the metal or plastic or even glass material. Listen carefully. So when you are speaking about the, either it may be wire drawing or tube drawing, stretching the material. So whenever there will be certain thickness of material is there, when you wanted to apply pressure in a tensile force, if you apply tensile force, obviously it will be stretch the material. Whenever by applying a lot of pressure to stretch the material, what will happen? Length can be increased, diameter can be reduced. Okay, so either it may be a plastic material or even glass material or any ferrous or non-ferrous materials. So what are the desired shape? It is a simple shape. Complex shape it is difficult to do because the mold and that mold preparation cost will be very high. That is why a simple shape, a square, rectangular, polygonal, so any simple shape products can be easily done by through wires and tube. Especially in a wire drawing process, almost all the electric wire insulation. So wherever in household applications, all the wires 3 by 18 and 5 by 24, like there's some gauges will be there. In that electrical wiring, obviously you can able to use this wire drawing process, and it will be some steps to be required to have a certain thickness of the wire inside, how the cable will be performed. And let us discuss some more details about this metalworking process in detail. In general, this wire drawing process, it is a very simple process. Here, just you can elongate or stretch the raw material by applying some machine, some equipment like some presses or some of the elongating machine to be used to enlarge the material. And in this process, what will happen? Rods made up of steel or non-ferrous metals or alloys, which are pulled through a conical die. So, for example, if you see the die is very important. So, whatever the die pieces. So here the material can pull out the small opening called die. Small opening called die. So based on this thickness only, how much diameter can able to reduce, that only can able to change the cross section from the large cross section into a small section. And because it is a cold working process, a lot of pressure, lot of force, tensile force is required to change a simple shape also. Okay, so that is why the wide drawing, it is a simple process. And in this process, either rods, any type of material, ferrous or non-ferrous or ceramic or plastic or even glass, some glass materials also can able to transfer it the length, okay, increase the length, reduce reduction of the diameter. And obviously this cone, here you can see that the cone angle also should kept approximately 8 degrees to 24 degrees. So obviously based on that conical shape, the raw material can be pulled easily by applying the lot of pressure. Okay, for even human being cannot able to elongate, stretch the material. Obviously some machine equipment, some semi-automatic and fully automatic equipment to stretch the material easily. Okay, so that is why as long as the material is pulled through the cone, what will happen? It undergoes plastic deformation, changes its shape, gradually undergoes reduction in its diameter. Obviously, for example, there will be a rectangular shape. This have to be put in this case. This will call it as a length, and this will be diameter. Obviously, when you are putting this wide drawing process, the diameter can be reduced. Obviously, length can be increased. Okay, so here the diameter is reduced. So say it is D1, say it is D2. So D1 always greater than D2. So D1 to D2 reduced length, and length L1 is less than L2. Length can be increased. Initially, suppose it is a 10 mm is there, if you enlarge it 20 or 30 mm can be enlarged. Length can be increased. Diameter can be reduced in this process. So that is why in this wide drawing process, because it comes under the cold working process. Obviously, we need to understand clearly how the diameter can be reduction and length can be increased with a simple process called wide drawing process. Okay, at the same time the length is increased. That is what here I explained in this simple steps of the wide drawing process. Okay, coming to all this material, I have collected some of the sheet metal study notes from the mechanical engineering from the international journals. Some Journal of Mechanical Engineering journal. I have collected this material so that this some more interested diagrams you can easily understand. We'll discuss in detail. Let us see this is the simple concept of wide drawing. So what I have discussed earlier, now we can able to understand clearly with the uh, understanding with this diagram. So look at, so where you can apply the force, where will be the die angle or cone angle, and where will be the drawing die, we will also call the drawing die, and this wire or rod, how you can able to stretch the rod or stretch the wire based on the requirement of our application. Okay, so look at these concept mainly depends upon the usage of that material. What type of material can be used? Either it is a ferrous material can be used, or non-ferrous material can be used, or ceramics, or any plastic. What are the material to be used? Depending upon the material, we should be able to discuss the elongation properties, how much strength is required to stretching of that material. That you should be able to study and understand. Then only can able to apply this wide drawing principle. The first point you can look at, check up, the dies tend to wear out too fast due to the continuous rubbing of the metal being pulled through it. So here you can see this is called drawing die, up and lower level. Okay, So whenever by always by reducing the diameter, obviously length can be increased. So whenever while performing this wire drawing operation, so much rubbing while pulling, it will go inside and come inside like that. Due to that rub, what will happen? The wear dies will be tend to wear. So whatever the dies to be used here, we should have a limit. This die can be applicable for certain amount of material. So for example, 10,000 components can able to perform. So suppose if you wanted to increase more again, you should do some maintenance work for finishing. Suppose any rust formation, the material can be removed. Again, you have to be clean it and you can have the correct size and shape of that component. Okay, and hence very hard materials like alloy steels, tungsten, carbon, or even diamond. So that also a lot of pressure is required. And if you the die always that workpiece material will be length than this die. So if this is die, it is more strength of the workpiece means this will be more spoiled due to wear can be occur. So this die will be spoiled automatically. The final outcome can be not get properly. So that is the another interesting point we would like to add. And another thing is, if it is a one pass, for example, how much amount of diameter can be reduction, either one pass, that you should also calculate a reduction, and the cross sectional area is achieved is about 20 to 30%. So for a single pass, maximum amount of reduction will be taken place 20 to 30% of reduction only. So further in the second reduction again she cannot have same thing. It may be reduced to some 10 to 15. Again some 4 to 8. So like that the reduction initial time some more percentage, say some 40% reduction, next 25%, next 10%. So like that, even one pass, how much reduction is possible to reduce, that you can do it. In the second case, automatically we cannot reduce the second pass the same amount of the reduction. Obviously, it can be reduced to 10 to 15%, and third also 4 to 8. So why? Because if always when you wanted to same moment means you cannot able to fit into the small opening called the die. Suppose in a wire drawing plant, what will happen? The wire has to pass through the several dies progressively. Obviously, the main intention is reducing the diameter in order to achieve the length can be increased. So, whatever the amount of reduction diameter in this case, that same in how many passes required, you should able to calculate it some design parameters. Okay, so that design parameter for one pass, how much amount of percentage reduction will be taken place. This is called single pass. Hmm? Single pass. In the second pass, how much amount of material can be reduction. Third pass, how much amount of material can be reduction will be taken place. So this is what one interesting concept of the wire drawing. And apart from that, however, the wire passes through the dies, what will happen? The plastic deformation takes place. So in general, you have studied the stress strain diagram. Whenever the stress y-axis is the stress and strain, how you can able to have this stress strain curve also. So what are the various stresses will be taken place, and where it can maximum strength can be achieved. After that, how much amount of stress it may be break or failure point will be taken place. This and all I have studied in the strength of materials or mechanics of solid subject in detail about the what is the stress strain diagram for a brittle material, stress strain diagram for a ductile material. You can refer the any one of the mechanics also textbook who can understand clearly about the stress strain diagram, how we can able to do the performance of that materials. And whenever the strength increases, what will happen? Its capacity is further undergo plastic deformation decreases. Whenever the strength can be increased, plastic deformation can be decreased. That is why initial stage maximum amount of reduction takes place. In the second case, we cannot act as same 20 to 30% reduction. It obviously it may be declined to 10 to 15%. In further, again it may be reduced to 4 to 8 or 2 to 6, etc. Okay, that is what about this important concept of the white drying. And another interesting one, whenever from time to time it will be heated or cooled. So obviously very few hot drying process where you can use the hot drying. Suppose some what you call ferrous materials and all, it cannot able to do for stretching of the material. Obviously, it can be heated. So when you wanted to heat it, what will happen? The recovery, recrystallization, grain growth will be occur. Obviously, it can be easily elongated or stretch the material easily. So that is why some ferrous metals applications you can prefer the hot working, and obviously other is simple diameter and all, we can prefer the cold working process, which can really easily stretch material by application of the pressure or force. Okay, and that is what about the process of removing all those things. We will call it as the work hardening or strain hardening. Okay, so this process obviously we'll call it as a in-process annealing. So already in any heat treatment process, what will happen? So when the heat treatment process, heating, holding and cooling. So obviously if you take any annealing process, the material can be heated certain temperature and holding for a period and cooling, the remaining cooling at reached at the final stage. The process will call it as a heat treatment. Obviously the main important heat treatment process are full annealing, process annealing, spheroidized annealing and hardening, normalizing, etc. These type of process will call it as a heat working process. The main purpose of annealing is to relieve the internal stresses, or you can able to improve the mechanical properties, electrical properties and thermal properties are the main application of all this heat treatment process. That is why the main concept of white drying, if you that dye and the workpiece in the sense either wire or rod to be plays an important role. Always that dye should be more stronger than this workpiece. Then only you can able to along or stretch the material easily by applying the force, tensile force. Yes or no? So this one, and here how much this is the angle alpha dye angle. Okay, here one alpha and here one more alpha. So obviously the how much amount of dye angle should be kept so that the uniform reduction of the diameter can be takes place. Obviously that leads to be a good formability application can be obtained. I hope the student can understand clearly. This is the basic concept of the white drying process. Let us see the how the principle involved in this wetted drying. So in general, the main aim of this white drying is to make the material will be soft or ductile. Again, the process of drying may be smoothly carried out. Even if we take a simple flexible white plastic material, when it is elongated at certain state, it will elongate. Some breaking also will be occur. So that is why if the material is soft, obviously the process is very simple. But the material is hard, obviously you can able to add some forces to apply some machines like presses etc. can be used. And another interesting one is the metal rods are to be drawn into wires, must be clean. So this is what here you can see. Whenever this workpiece, either wire or rod, when you are introduced to a small opening called die, first you should need to clean properly. Either you have to clean the die as well as the wire or rod also. Why? Because any foreign particles, any dust particles will be kept inside so that some surface finish can be damaged and so that the smooth and mirror-like surface finish component cannot be achieved. That is why when you wanted to perform this white drying, we should clean both die and workpiece. Workpiece in the sense wire or rod. So that is what I told. The one pass 20 to 30 25 to 30% amount of reduction will be taking place. Even any wire, drawing plant, it is a one setup will be there. The wire has to passes through a small opening dice, which is a progressively. So the main intention is reducing the diameter at the same time to achieve the required reduction in the diameter. For example, so there will be a 20 diameter is there. How you can able to reduce 20 into 10? This is called 10 diameter. So obviously the length is increased, L plus delta L or L plus some changing of this length. Okay, and the length can be increased, diameter can be reduced. This is the more diameter. This can be reduced 20 to 10. How you can able to do reduction takes place, and length also some 50 to 60 or 70 or 80 based on the proportion of the length to width ratio. Okay, so this is what about the another principle involved in this white drawing. And let us see the, suppose if necessary there are pickled in an acid bath or dissolve the oxide layer to present on the surface first. So what I said earlier, you should clean the dye and wire or rod. So if you are not able to clean properly, you can able to keep that acid. Okay, so obviously you can pickle in an acid bath to dissolve any oxide layers, and rust particles can be cleaned easily, so that you can able to perform better. And even in the front end also there will be tapered down. Why? Because that wire or rod should be passed smoothly. Okay, if it is a, that's what formally fix in that two openings in a wire drawing machine. And one another interesting one is, during wire drawing what will happen, the great deal of heat is generated due to friction between the wire rod and die. So here, even though it is not heated material, even though it is not heated, wire or rod cannot be heated, but while workpiece can be entered through a small opening die, due to rubbing action some heat can be generated. So if the continuous rubbing action, heat can be generated. That is why you need to have some cooling. Okay, we should be able to provide some cooling technique in order to have a smooth, okay, smooth finishing of the application. Okay, so that's why due to friction the heat is generated between the wire rod and the die. So what happened, your intention is you should reduce the friction. Obviously for that you can use some dry soap or synthetic lubricant. Again the lubricants are different type of lubrication, solid lubricant, liquid lubricant, gaseous lubricant, variety of lubricant is there. Even in engine also, obviously that lubrication oil is very very important for smooth functioning of the engine, piston rod and connecting rod, etc. That is why you can see the another interesting one. Whenever the drawing machines can be arranged in a tandem, so some setup will be there where initial raw material come through, and how the dry, and where we will extract or stretching of the material, and how do you clean the things, how do you cut cutter machine. So there will be a sequence of process will be there, so that the wire drawn by the previous die may be collected in a coil form, some circular form. How we can able to cross like that circular form, it can able to perform. Okay, so even though the diameter becomes smaller and smaller, the linear speed of wire drawing will be increased. So the when you wanted to reduce the diameter in small, obviously speed can be increased, so that the elongation takes place effectively. This is the some basic principle involved in the wire drawing. So this way the setup, I hope the student can understand clearly how you can able to process the wire initial to finishing of the that wires. Okay, look at in this case in general. So there are dies. These two are the dies, and how that material will enter through wire rod. Okay, and this drawback, it will be rotated. So it can be rotated either it is a clockwise direction or anti-clockwise direction. How we can able to elongate, even you can see heating coil also how they can put some rotated. Okay, so that even metals also, when it elongate properly, what type of diameter and the specific setup also needed to arrange. Okay, so this is what a speed control wheel. So when you wanted to reduce the thickness, speed can be increased. Okay, so this is the and the process after finishing drop block, how it will be. The exact amount, the diameter of the wire should be either 5 mm or 10 mm. How much amount of reduction of the diameter, based on that some steps. So initially wire try enter to the die, and some drawback will be there, some speed control valve. So whenever the diameter to wanted to reduce, speed can be increased. And even final finishing also, any rust particles and any heat due to friction takes place, some heat can be generated. In order to avoid that heat, can able to provide some lubrication. So obviously with this case, the exact amount of the raw material can be obtained with the simple wire drying process. And look at what are the main advantages. What are the advantages of wire drawing and rod drawing? So based on this different type of obligation, first and foremost thing is, for any wire drawing process, finally we can achieve the good surface finishing. So that is what, before starting the raw material should be clean. Even the die parts also will be clean effectively, so that no need for the further finishing. So whatever the drawn from the sheave or speed control wheel, and it final finishing can be obtained exact amount of diameter with the smooth finishing can be obtained. And another interesting point is adaptability to mass production. So whenever it is a simple diameter, less diameter, and all the mass production, for shift 8 hours, you can able to produce some 40 tons or 20 tons of the material in a stipulated time, 8 hours. And one other thing, closed dimensional control. What is closed dimensional control? Especially you can see the in engine spark plug. The spark plug, exactly wherever you can fix the spark plug, it should be fixed properly, so that they should maintain the close dimensional tolerance control. So if the 10 mm means exactly 10 mm should be there. So if you allow for plus or minus 5 mm means it cannot fit, it cannot reduce. That is why wherever when you wanted to apply the closed dimensional control, initially the die should be clean. The raw material, either rod or wire, also should be cleaned properly. Either it is in oil bath or acid bath or by rust cleaning methods. Any one method can be adopted in order to have a closed dimension. So that means if you have a 5 mm diameter at the final output, so exactly the starting it may be vary some 6 or 7, by reducing all those things under the final, it should be very clean and neat, and the exact dimension should be obtained. So if you are asking 5 mm, if you write 4.9 and 4.8, it cannot able to fit. Okay, so even that industry also, they will specify we required the wide drawing process of the 5 mm to plus or minus 0.01 or 0.02, up to that micro level only they can allow. So if you are asking 5 mm, if you provide 6 mm means it may be rejected only. So that is why you should make an attempt, you should give the instructions to the quality control engineer. We need some exact dimension, so that the closed dimensional control will monitor, will identify certain components, certain set randomly. In that, if it is not exactly that 5 mm diameter, obviously it may be rejection only. So that is why obviously with this they can improve the dimensional properties. And coming to the economical benefits also, very less number of components or setup will be there, even for large size and shape of wide drawing components can be obtained in this process. Okay, so these are the some important, major important advantages of wide drawing and dry drawing. So whenever by this process, good surface finishing, it is a main adaptability to mass production for shift ton and tonnages of raw material can be performed. So you need to focus on close dimensional control. Every half an hour, every 1 hour you can able to monitor the dimension of the final component randomly. So, and obviously which will improve the dimensional parameters. The finally the cost, economic benefit. Okay, so if you wanted to put large, high costly equipments under, it may be a problem for putting the manufacturing cost. So that is why, in order to reduce the manufacturing cost, the initial cost may be more for the semi-automatic, fully automatic machines for extracting machines. And that. So you have to select how much amount of material is there, how much amount of the finished product to be obtained. If you know that, you can able to determine some design calculations, then you can apply in some industry requirement. Okay, so this is what about the advantages. That is what complete details about the wide drawing. But what is my tube drawing? This is the people are thinking that both are same, like that they will say, oh, it is not at all same. Wide drawing is different from the tube drawing. So look at the tube drawing. In the diagrammatic representation itself, you can clearly understand. A layman can easily understand the what is the principle and diagrammatic understanding of the tube drawing. So look at, there is a 4 stages. First stage is how the method to be used for a tube drawing. It is a convention tube drawing. Whenever there will be mandrel to support the dies and the tube being held in between the die, and the pulled by draw bench or draw bench type of equipment, and they should keep the mandrel. So if your mandrel is not, the mandrel should be either stationary or floating mandrel, both should be important depending upon application. Which type of mandrel is suitable for that application, we can prefer the either floating mandrel or that mandrel. Okay, floating mandrel or mandrel supported thing should be required. Okay, so the first one is it is a common method for using for tube drawing, and the second, this is a floating mandrel to be used for to float the mandrel so that some gap and some uniformity can be obtained. The third diagram, which wherever you can need to have a long circular rod to control the size of the tube. So inside the tube bore should be reduced. It means obviously the third setup can be long rod can be used in the same setup only. And finally, you can see this diagram. They clearly understand neither a mandrel nor bar, and controlling the size of the bore is difficult. Okay, here we are not using mandrel, we are not using bar. Only the controlling the size of the bore is somewhat difficult. Some technique should be adopted for transforming the material in a tube drawing process. There will be some tubes. Okay, opening, how much distance you want the tube, how much specifications is required. That only very important factor in this tube drawing process. All these information also are collected in the some of the sheet metal study notes for the mechanical engineering process. Look at another thing is applications of this drawing. Okay, that may be tube drawing or wide drawing, whatever it may be. So look at these are the general application of tube drawing process. That is means tube drawing doesn't mean that manufacturing a tube from a solid material. So here it is very interesting. Tube drawing doesn't mean that manufacturing a tube from solid material. If there is a one solid material is there, in that you can able to perform a some tube bore. No, it is not at all. Only you should able to some workpiece is there, how you can able to transfer the diameter. The diameter can be reduction will be taken place, and the length can be increased, and this application will call it as a tube drawing. And look at some of the various arrangements, which is specifically used for the tube drawing process, which can shown in this diagram. So different variety of diameters, different variety of the geometry, and different variety of length can be seen. The student can clearly understand how best you can able to process in a tube drawing process. So this is why this comes under the initial industrial applications for the tube drawing, where you can able to perform solid raw material into reducing the diameter part. And coming to this another application, tubes with the joints, especially whenever you can add some joint, obviously whenever joining any metal, similar or dissimilar metal, obviously you can use the term welding process. Okay, so welding means either it may be arc welding or gas welding, or there is a variety type of weldings are there. Usually by joining the two joint, what is the economical type of welding can be preferred, that weld application only can be performed. So even usually the weld joint is made up of an electric resistance welding process, and such tubes are referred to as a ERW tubes. Okay, so there is electrical resistance welding tubes. Okay, the size of the tube or pipe is indicated the size of its bore in mm only. Whatever the size of the tube depends upon the how much bore size that can be equated. And since there is a requirement of the tube is so large, so the tube for a certain amount of cross section means you can easy. Suppose the tubes are very large, suppose seways of the water, some canals, so all this comes under that is a special rolling process can be used, that we'll call it as the rotary piercing process has been developed. When you wanted to have a large requirement of the tubes preparation, obviously special rolling process which is called the Manensman rotary piercing process, it is obviously preferred for the large type of tubes. So, and another thing is, look at this, how the mandrel inside, and there will be a hollow part, and this is different from this elliptical hollow tube. Suppose here it is some rectangle one, instead of that some elliptical hollow tube is there. How you can able to have the structures easily, and the strength and the mechanical properties also can be improved effectively. And look at this tube drawing. Once again, the concept with the simple diagram. So this is also in the mechanical study material. In that you can see this the die. So say it is die 1, die 2. How much opening? And this is the opening. And here the large diameter tube will be converted into small. So this you can take it as a capital D1, large diameter, into small d1. So how the d1 will be converted into small d1 with using of a mandrel. So obviously in the white drawing there is no mandrel at all, but in a tube drawing obviously the hollow shape should be there. We should provide the mandrel. Mandrel means depending upon the reduction of the size in the diameter. So that size of the diameter mandrel can be best preferred for in this tube drawing. Okay, so and another thing is as long as the billet moves forward and keeps rotating, some tearing action takes place, so that the length of the billet can be improved properly. And another thing is the result is roughly formed a seamless tube is a elliptical cross section. So how we can able to perform this elliptical cross section, and this is a rectangular cross section. This concept also will be applicable in the tube drawing process. This roughly formed seamless tubes is further rolled in a plug rolling mill. Another interesting is plug rolling mill, and the final operations of sizing and reeling and finishing all are further conducted in the cooling the tubes to improve the size and finish of the bore tubes. Okay, so even if you wanted to final preparation of the reeling and sizing process, you should be able to conduct the cooling tubes to improve the size and physical or finishing tubes can be perfected. Okay, so this is what about the basic difference between the white drawing and tube drawing. I hope the student can understand clearly about the white drawing and tube drawing. And in general, in this metal working or mechanical working of metals, This wide drawing and tube drawing is one of the most widely used in the industrial applications like this. Okay, variety of sizes of the shapes can be performed in this wide drawing and tube drawing. I hope the student can understand clearly in this video, and in the next video would like to discuss another interesting topic. Okay, so thank you student, thank you for this session.
Like, share and subscribe. Hit the bell icon for more updates.